Perfect. Perfect. Thanks for the introduction, and thank you everyone for attending my talk. I'm Hadi. I'm a second-year PhD student here at Virginia Tech, and today I'm going to discuss about the future of content blockers. So briefly about my research background. So I apply software engineering techniques to security and privacy problems. Specifically, my ongoing research applies principal software debugging, fault localization, and software testing techniques to identify and localize the semantically problematic JavaScript codes, such as advertising and tracking scripts. So let's talk about something in bigger picture, and then we'll see a concrete example to understand the problem. So there are two key stakeholders in ad blocking: advertisers and trackers, and content blocking tools. Advertisers and trackers are engaged in an escalating arms race with these privacy-enhancing content blocking tools. On one side, we have these publishers who serve ads and trackers on their sites for monetization, whereas on the other side, we have these content blockers who try to block these privacy-invasive ads and trackers by using filter lists. Now let's understand the problem using real-world examples. NBCnews.com is ranked 21st in the news and media category in US. So on this website, we see the script named app, then there's a hyphen, and then long identifier.js. The yellow box on the slides exactly shows the URL of the script. In short, I'm going to refer the script as app.js in future. This script is sending requests to taboola.com, which is very popular ad exchange to help publishers and advertisers in driving user engagement. Since this is a tracking activity, so it's shown in red color. This script is also sending requests to get the functional content of the website, like a watch live button and login for the users of the website. Since this is a functionality, so it's shown in a green color. This is one of the conflicted situations for the content blockers because they have very limited options to handle such case scenarios. Let's just walk through the three possible approaches for these content blockers and discuss their shortcomings. The first and the obvious one is to just simply block the network request to taboola.com. However, this can easily be made ineffective by moving content to any CDN. For example, by changing taboola.com to CDN taboola.com. Now, the second choice is to decide if you are going to allow app.js or you are going to block it. Allowing it means simply adding this URL to the allow rules of the filter list. But again, this incentivizes web developers to combine functionality in tracking scripts to simply avoid these content blockers. Whereas blocking it means compromising functionality. As you guys can see on the slides as well, the watch live feature has completely disappeared and navigation and login button becomes totally unresponsive. So users tend to simply disable content blockers if they adopt the later date. Now, this means that content blockers cannot make a reasonable block or allow decision for such mixed scripts. This issue maps to a well-known problem in a software engineering community where we attempt to localize faulty functions based on whether they pass or fail test cases. We adopt a very well-known fault localization technique from software engineering to solve this problem. Here, automated fault localization is used to localize tracking functions in the mixed script on the basis of its activity. On the slide, you can see the function I in the script app.js that initiates tracking requests to taboola.com. After identifying the function, we simply terminate the calls to this function from script app.js instead of blocking the whole script. This renders the website nbcnews.com properly and without any breakage. Now, before we conduct any large-scale deployment for our approach, we actually wanted to investigate the prevalence of mixed scripts widely on websites. For this, we conducted a longitudinal experiment on the frequency of mixed scripts on 100K websites over the past 2 years. So last year in 2021, we saw 42% of the scripts as mixed, whereas this number increased to 49%, which is a huge jump in 2022. Therefore, these results further motivate us to do some JavaScript code analysis of these mixed scripts like app.js. Now let me explain how automated fault localization approach can be used to localize problematic functions in mixed scripts. We crawl the website and capture the complete network request profile. Then we use filter list to label network requests as either tracking or functional. And on the basis of an initiated request count, we annotate the entity. For example, script utag.js is initiating 132 tracking and 161 functional requests, whereas the function loader and Firecourse are solely initiating tracking and functional requests, respectively. This ends up with script utag.js as mixed, and further scrutiny helps us to find that function loader exhibits solely tracking behavior and can easily be blocked by content blockers. So we have designed experiments to compare the effectiveness of method level blocking versus script level. So in script level blocking, we block all the scripts that have similar behavior like app.js on nbcnews.com. Such scripts are referred as mixed scripts. Whereas at the method level blocking, we only block the tracking methods in the mixed script, such as method I in script app.js. Now we conduct our experiment in the two phases. The first one is an automated analysis of 100K websites. In automated analysis, we are going to compare, obviously, the blocking of mixed scripts versus the breakage after blocking the tracking method in mixed scripts. And to compare the breakage automatically, we compare the missing DOM media tags of control experiment with the blocking scenario. For example, image source 2 is missing in the blocking scenario. We compare the URL of the missing tag with the filter list to label it as tracking or functional. If it's functional, then it's considered as a breakage. Now let's talk about the results of the automated analysis. So missing functional image tags in script level blocking was around 35K, and it dropped to 14K at method level. Missing functional iframe tags in script level blocking was around 18K, and it dropped to 11K at method level. And missing functional script tags in script level blocking was around 52K, and it dropped to 28K at method level. These results clearly show that method level blocking is much more effective as compared to script level blocking. Now we further complement our automated analysis with qualitative manual inspection of 383 websites. Here we label website breakage in terms of 4 categories: navigation, which includes the links to the internal web pages. Second is single sign-on, which includes the user sign-in using credentials like Google or Facebook. Third one, we have appearance, which include media appearances, except for advertisements, just like the scrolling behavior for the websites or the HTML tags. Lastly, we have like additional functionality, which includes everything that does not fall in the above mentioned categories, such as the dark mode or website settings, etc. And then we classify each page load at 3 levels of breakage. No breakage when everything looks good. Minor breakage when we see slight abnormal behavior. And last, we have major breakage when something is totally unusable. The results of minor breakage on 383 websites show that 15% of the websites have minor breakage in script level blocking, while around 9% websites show minor breakage in method level blocking. In short, we see less minor breakage on 7% of the sampled websites. Similarly, the slides show the results of major breakage on 383 websites for those 4 categories. We find that 26% of the websites have major breakage in script level blocking, while only 7% of the websites show major breakage in method level blocking. In short, method level blocking recovers functionality in 48% of the sampled websites that have breakage due to script level blocking. Again, these results validate the findings of our automated analysis as well. Let's just conclude everything. Hopefully, I have convinced you guys today that the automated fraud localization techniques can be really fruitful for content blocking, especially as advertisers move to mix advertising and tracking and functional resources together. So these principal software engineering informed techniques can actually assist in creating the next generation of the content blockers. Since I cannot take questions live from the audience, I would just like to just get some questions on Slack, or you can just email me at my email on the slide as well. So yeah, that's pretty much it. Thank you so much. Thank you so much for listening and attending my talk. Over to the host.